This is section 13.2. We're going to look at special right triangles. These triangles are going to be 45, 45, 90 triangles. That means their angle measures are 45, 45, and 90. You've seen this type of triangle before. This is called a right isosceles triangle. Right because one of the angles is 90, and isosceles because two of the angles match. Okay, let's review just a little bit our Pythagorean theorem. A triangle must be a right triangle, and two of the three sides must be known. This is what you need to have to use the Pythagorean theorem. So we got leg squared plus leg squared equals hypotenuse squared. We've written that as a squared plus b squared equals c squared. So for example, leg squared plus leg squared equals hypotenuse squared. We know 6 squared and 8 squared. We don't know c squared right now. But if we add 36 and 64, we get 100. We want to unsquare that c. So you have to unsquare the other side. Square root of 100 is just 10. Now it could also be negative 10, but since we're talking about the length of a side of a triangle, it's got to be positive. That's how your Pythagorean theorem works. Shh. Number 1, let's find x. Notice how we have two congruent sides of a triangle. That's going to create congruent angles here. Just pointing that out. Leg squared plus leg squared equals hypotenuse squared. And I put a c there for the hypotenuse. The hypotenuse length is actually x, so maybe I'll just put an x there. 5 squared is 25 in both of those spots. So 50 equals a number squared, which means your number is the square root of 50. Now, if you type that in your calculator, it's going to give you a decimal. It's going to be a little bit bigger than 7. We want an exact answer, though, that's simplified. So we need to work on this. What perfect square goes into 25? Oh, sorry. What perfect square goes into 50? How about I just give you the answer? It's 25. Square root of 25 is 5. And the square root of 2 doesn't simplify. Those are the skills we learned in our last section. So let's look at this example. If your legs are 5, then your hypotenuse is 5 times the square root of 2. Now, if those two angles are the same that we talked about in the beginning, then they're both 45. Hopefully you learned something there. We're going to do the same thing again for number 2. Notice how your legs are the same. That creates congruent angles, which means they have to be 45 degrees. So these are right isosceles triangles. Pythagorean theorem says 12 squared plus 12 squared has to equal your x squared. Shh! So 288 equals x squared. That means x is the square root of 288, which probably doesn't look that exciting to you. But it doesn't have to be complicated. We know that 144 goes into 288. The square root of 144 is 12. And that's why we broke it up that way, because we wanted to get a number times a radical. Does this look familiar to you? If your legs are 12, then your hypotenuse is 12 square root of 2. Okay, well, that's for 5 and for 12. What happens if your legs are any number, like x, for example? If those lengths are the same, let me use a different color here. If those lengths are the same, then obviously those angles are the same. So this is all 45, 45, 90 triangles. what would this guy be? Okay, let's look. X squared plus x squared has to equal that c squared. X squared plus x squared is 2x squared. We want to solve for that c. So let's get c by itself. We need to take the square root of 2x squared. And that's what c will equal. Now this looks complicated because there's a variable there, but again, it doesn't have to be complicated. You can change this to the product of two radicals. Now, one of those is a perfect square. 2 is not a perfect square, but x squared is. What's the square root of x squared? It's just x. The square root of 2 doesn't change. Your hypotenuse is always going to be whatever that leg is times the square root of 2.